Hello and welcome to our lesson on separation techniques looking at chromatography, and this is our second lesson on chromatography. So far we have looked at the basic chromatography that you can see there on the right hand side with the coloured dots, and it kind of works some of the time. And if you've done these practicals in class, you know that it smudges all over the place. It's really quite difficult to compare chromatograms with each other. It's very easy to get muddled up, and it's not particularly accurate. And so we need a better way of doing chromatography that is more accurate and easier to read and easier to measure. And this is known as thin layer chromatography, which is the one you can see on the left hand side. Now, it's called thin layer chromatography because you have a glass plate with a thin layer of aluminium silicate painted on it. So the glass plate is the stationary phase. It takes the place of the paper. And really that's the only change. So, the box is the same, the solvent is the same, the lid is the same, but you can see on the left there, it's a glass plate with this thin layer of aluminium silicate, and the solvent will move up the aluminium silicate, depositing the pigments or the dyes or whatever it is. Now, the reason this is more accurate is because the solvent will move more quickly. The solvent moves more evenly, so it's going to pull up that the dye much more evenly, and the spots are more distinct, so you don't get that massive spread of colour that's difficult to read and difficult to know where to stop with the RF value, and so it gives you a better or an easier RF value to read, and therefore your results are going to be more accurate. Now, a step up from thin layer chromatography is something we couldn't possibly do in the lab. It's a very expensive piece of equipment and you need specialist training. So if you ever want to do a scientific job that has relatively low stress, this might be the job for you. This is gas chromatography and mass spectrometry. Now, very fancy words, but basically this is your gas chromatography. And rather than a solvent dissolving the substance and pulling it up the paper or the glass plate, this is a gas pushing the substance around the chromatography column. And then the computer that does the reading out and understanding of that information is called the mass spectrometer. And again, like I say, you have to be specially trained to use this, and it's extremely expensive equipment. So let's have a look at it. So how does this actually work? Well, as I said previously, the carrier gas is going to push a substance around the column. It's still called the column, even though it's a spiral, okay? And it's going to come through here, through the detector, and then it's going to be read off on the computer. Now, the carrier gas is inert. That means it's unreactive. It's not going to react with any of the substances. It's simply going to push that substance through the column. The reason we need a carrier gas is because we're using extremely small samples. So this is really good in a crime scene when you've just got a little bit and it's not going to go very far and you really need it to work first time. So what happens is you inject your substance, your unknown substance, into the injector. So this is where your mixture is going in here, and then your gas is coming in from here and it's pushing it round. And as it goes through this column, some substances have what we call an affinity to the stationary phase. They like the column, and therefore they stay in the column longer. They're slower to come out of the detector. Whereas some substances have an affinity, or they like the mobile phase, so they like to move through quicker, and therefore they're going to come through the detector much sooner. So what you have here is the mixture starting off at I guess it's a bit like a race. They start off at the injector together, and then they move through the column. Some get to the detector first, and then what happens is the computer gets a readout, something like this. And the computer sees, okay, there's a spike here. That took 2 minutes to come through the column, and then it compares it to a database and says, okay, that substance there, it took exactly 2 minutes to come through that column. That's your petrol. Okay, I've got another spike at B. That's something else. C, something else. So in this example, you can see the mixture is actually made of 1, 2, 3, 4, 5, 6 different substances. And you can see the quantities there, not much of A and lots of F. So they're looking and seeing how quickly it's coming through this column. Don't panic, I'm not expecting you to have a go at all of this unless you want to, in which case pause the video and have a go. But I just thought I would give you this comprehensive paragraph just to make sure you've understood everything. So gas chromatography is used to analyse very small samples of chemical mixtures. Still talk about mixtures, it's still separating mixtures. The sample is inputted via the injector and carried through the column using a carrier gas. The carrier gas is needed because the sample is so small. As the chemical mixture travels through the column, the molecules with greater affinity to the stationary phase are slower than the molecules with a greater affinity to the mobile phase, so they take more time to get through the column. The mass spectrometer knows exactly how fast certain elements or compounds will take to travel through the column, and so it knows what is exiting and produces a graph called a mass spectrum. And here's a picture of the machine, which looks very expensive and highly breakable. So here's that chromatogram again, looking a little bit different. So what can we see? So a chromatogram gives us 3 bits of information. It tells us the number of compounds in the mixture, and that's represented by the number of peaks. So I have 1, 2, 3, 4, 5, 6 peaks. So I have 6 compounds in this mixture. It also tells us how much of each compound is present, and that is represented by the height of the peak. So in the red box here, which substance was present in the smallest quantity? So the smallest peak was A, and the largest peak obviously was F there. And it also tells us the retention time. It can give us that RF value indicated by the position of the peak. So I can see here that A had a shorter retention time, whereas F had the longest retention time. Okay, that's it for this lesson, guys. I'll see you next time.